Hello everyone, welcome back to this course called Design of Fixed Wing UAV. Today we will discuss some problems which we made based on the lecture, based on the last lecture which sir talked to you. So let us start with the problem. So the data is given: cruise speed is 45 meter per second and density at mean sea level is 1.225 kg per meter cube. CL alpha of the wing is given 5.156 per radian and CL alpha of the tail also given 3.38 per radian, and alpha at lift equal to 0 is -2 degree. We can write some data here. Mean aerodynamic chord is given 1.2 meter. Span of the wing is given 10.5 meter and Cm naught of the whole UAV is given 0.0928, as well as Cm alpha is given of complete UAV is -1.01217 per radian. Tail efficiency factor 0.89. XAC of the wing 0.3 meter and XAC of the tail is given 2.925 meter. So basically we are measuring this distance with reference to wing leading edge. So this XAC is nothing but the distance from wing leading edge, and this XAC tail also from wing leading edge. Tau is given 0.5, dou epsilon by dou alpha is given 0.375, epsilon naught is given 0.75. With this information, it is given then कि effect of the fuselage on the stability is negligible, and some useful formula also given, like CL equal to CL alpha into alpha plus CL delta E into delta E, and Cm equal to Cm naught plus Cm alpha into alpha plus Cm delta E into delta E, where delta E is a elevator deflection. So if suppose that if you want to consider only a stability, then this part only there, but if the controls will come, then this part will add, because when you deflect the elevator, then CL will change, and this is Cm equal to Cm naught plus Cm alpha into alpha. This is when you consider only a stability. When you consider the control, then Cm delta into delta E will come, where Cm delta is a elevator control power and delta is a elevator deflection. So nomenclature has their usual aerodynamic meaning. V is a speed, rho is a density, the lift curve slope of wing, lift curve slope of tail, angle of attack when lift equal to 0, mean aerodynamic chord, span, pitching moment coefficient at 0 angle of attack, pitch stability derivative of all UAV, tail efficiency factor. This is nothing but dynamic pressure on the tail divided by dynamic pressure on the wing. XAC, location of aerodynamic center of wing, location of aerodynamic center of tail. This is downwash angle, dou epsilon by dou alpha is a, you can, if you span using Taylor series, epsilon downwash angle equal to downwash angle at 0 angle of attack plus dou epsilon by dou alpha into alpha, and So we will solve first problem. The first problem is find the location of neutral point of the above fixed wing UAV from the wing leading edge. So in first question you have to find the neutral point. So you have to find the neutral point. See, the information is given, using this information you can find. So first you have to think that in which equation the neutral point will come. So it is obvious that when you write Cm alpha of the whole aircraft or whole UAV is nothing but equal to Cm alpha of the wing plus Cm alpha of the fuselage plus third part is Cm alpha of tail. But it is already given that Cm alpha of the wing, Cm alpha of the fuselage is 0, because it is in the question it is giving the neglect the effect of fuselage on a stability. So this will be the 0. And what is Cm alpha of the wing? It is nothing but CL alpha xCG by C minus xAC by C. It's a mean dynamical, you can put bar. And this is Cm alpha of tail is nothing but minus eta ST by S xAC of tail minus xCG divided by C bar into 1 minus dou epsilon by dou alpha. This is a complete expression of Cm alpha. So you have to find the neutral point. So at neutral point your Cm alpha will become 0. Cm alpha will be the 0 and xCG will reach at neutral point. So put Cm alpha equal to 0 and xAG equal to xNP in this equation. Let us make equation 1. So what you will get? 0 equal to CL into xNP by C minus xCG by C minus eta ST by S xAC of tail minus xCG become xNP, right, and 1 minus dou epsilon by dou alpha. So if you rearrange these equations, then what you will get? X neutral point will be xAC plus eta ST by S xAC of tail into CL alpha of the tail, CL alpha of the wing 1 minus dou epsilon by dou alpha divided by 1 plus eta ST by S CL alpha of the tail, CL alpha of the wing into 1 minus dou epsilon by dou alpha. Right, you will get this expression. So if you put all this value, what you will get? So just put each and every value from the data which is given. So your xAC is nothing but xNP equal to xAC is given 0.3, your xAC is given 0.3 plus eta is given 0.89, and it is also given in the question that the tail area is 1/4 of wing area. So your ST by S will be the 4. So 1/4. your tail area is 1/4 of wing area. So ST by S you can put 1/4. Next, XAC of the tail. XAC of the tail is given 2.925 and CL alpha of the tail is given 3.38. CL alpha of the wing is given 5.156 and 1 minus dou epsilon by dou alpha is given 0.375, okay, divided by 1 plus same thing except CLT 0.89 into 1/4 into 3.38 divided by 5.156 into 1 minus 0.375. So when you solve this, you will get X and P is nothing but 0.5193 meter. So this will be the answer of that question. So in second question you have to find the total lift curve slope of the UAV in per radian. So to solve the second question, we will solve here. So total lift curve slope of the CL alpha of the whole UAV is nothing but CL alpha of the wing plus eta ST by S CL alpha of the tail 1 minus dou epsilon by dou alpha. Sir, already given to you the derivation of this CL alpha of the complete aircraft equal to how you will get the CL alpha of the complete aircraft using CL alpha of the wing and CL alpha of the tail. If you use the first principle, that means lift equal to, in this case that means total lift of the aircraft will be the total lift of the wing plus total lift of the tail. So if you use the relation total lift of the UAV equal to lift of the wing plus lift of the tail, you will get this. So CL alpha of the wing is given 5.156 plus eta is given 0.89 and ST by S is given 1.4, CL alpha is given 3.38 into 1 minus 0.375 which is dou epsilon by dou alpha. So here you will get 5.626 per radian. This is nothing but CL alpha of the complete UAV. So you can see that earlier your CL alpha of the wing was earlier the lift curve slope was 5.156 when suppose that there was no tail, but if you add the tail, then total lift curve slope of UAV will increase. So here is 5.156, here is 5.626 per radian. So in the third question you have to find the static margin. So you know that static margin is the distance between neutral point and XCG with respect to the mean aerodynamic chord. So static margin is nothing but minus dou Cm by dou Cl, and also write a static margin in terms of Cm and Cl. So this expression you can manipulate this equation like dou Cm by dou alpha divided by dou Cl by dou alpha. This you can further write Cm alpha and Cl alpha, right. So Cm alpha, it is given in the question minus 1.01217, right, and CL alpha you have found out 5.626 per radian. This is also per radian, this is also per radian. So your answer will come 0.17 99 static margin, which is also distance between neutral point and xCG with respect to the mean endodynamic chord. Okay. So, this is the answer of third question, and you have to, in fourth question you have to find the location of center of gravity. So, in this case you know that okay, you have found out the position of neutral point, you have a static margin, also use this relation, you will find the xCG. So, if you use this, what will be the your xCG? xCG is nothing but xCG bar is nothing but x neutral point bar minus this 0.1799 static margin. This you can write xCG by C and multiply C in this side. What you will get? You can write x neutral point by C. So, C will cancel. So, x neutral point only will be there and 0.1799 multiplied by C bar, right. So, this neutral point you already found out how much it is, 0.5193 neutral point minus 0.1799 into C bar is 1.2, right. So, your answer will come 0.3034. This is the position of center of gravity of UAV from the wing leading edge. This is the answer of your fifth question. So, in sixth question you have to find the, okay, this is in meter. So, in sixth question you have to find the tail volume ratio. So, basically tail volume ratio tell us the how much stability UAV or aircraft has. See, tail volume ratio in this case means horizontal tail volume ratio is ST by S, C bar and tail arm, which is nothing but XAC of tail minus XCG. So, ST by S is given 1 by 4 and XAC of the tail is 2.925, right, and XCG is 0.3034 divided by 1.2 C bar. Okay. So, what you will get? You will get approximately 0.5461625. This is nothing but your tail volume ratio, horizontal tail volume ratio. So, in sixth question you have to find the tail setting angle, ki how much tail setting angle is required in order to get the desired Cm naught value. So, let us solve this also. So, you know that, see, think about that ki okay, in which equation the IT is coming, tail setting angle. So, it is obviously Cm naught. So, Cm naught is nothing but Cm naught of the wing plus Cm naught of the tail. Okay. So, Cm naught, further you can write Cm naught of the wing, CL naught of the Cm naught, you can further write CL naught into XCG by C minus XAC by C. And what is the Cm naught of the tail? It is eta ST by S into XAC of tail minus XCG divided by C into CL alpha of the tail IW minus epsilon IW plus epsilon naught minus IT. So this is nothing but your Cm naught of the whole UAV or aircraft. But in this question it is given that ki Cm naught of the UAV which is 0.0928. What is CL naught? CL naught you can find using this relation, CL equal to CL alpha of the wing, alpha minus alpha lift equal to 0. So if you put alpha equal to 0, what is your CL alpha? CL alpha of the wing is nothing but 5.156, it is per radian. And what is alpha lift equal to 0? It is minus 2 degree. So minus minus will become plus 2 degree. You convert this into degree, you will get approximately 0.1799. So this is in per radian, na? This is in degree, that's why we have converted this into per radian. So per radian and radian will cancel. So your answer will be 0.1799 CL naught. If you are putting alpha equal to 0, you have to put naught here. So you can put this value here, 0.1799. XCG you already found out, right? How much is 0.3034 divided by C bar 1.2 minus XAC is nothing but 0.3 divided by C bar 1.2 plus 0.89. Okay. This thing ST by S, XAC minus XAC tail minus XAC by C, you can write tail volume ratio, right? It's we already defined. So tail volume ratio is nothing but which we got, it is how much? 0.5461. Just take 4 digit. CL alpha of the tail is 3.38. Be careful that it is per radian. So it is, you can convert this into per degree, then it will be easy because here you will put in degree all this number. So wing incidence angle is 0, and what is epsilon naught? It is given 0.75, right? 0.75 degree minus IT. Here be careful that CL alpha of the tail is in per radian and epsilon naught and IT is in degree. You want to the answer in degree, so you have to convert these things per radian into per degree. That's why we multiply this. So if you solve this, you will get IT approximately. Tail setting angle is nothing but 2.468 degree. Just you have to solve this. We have put it all the numbers. Just rearrange this. So in 7th question, with this given information, what will be the total lift coefficient at 0 degree angle of attack? Means you have to find the CL naught of the complete UAV. See, CL naught of the wing we have already found out, 0.1799. So when you add the tail, then how much CL naught the tail will produce? You just have to find out, and this add this thing, you will add this two, you will get the answer. So let's find this also. So CL naught of the complete UAV equal to CL naught of the wing plus CL naught of the tail, you can say. So what will be the CL naught of the wing? You have calculated. Let's put first formula and then we will further proceed, right? And CL naught of the tail is nothing but eta ST by S CL alpha of the tail IT minus epsilon naught. So this is nothing but we have calculated that what is the CL naught which is coming. So CL naught is nothing but, we have found out 0.1799, right, plus eta is 0.89 into ST by S is 1.4, CL alpha is 3.38, which is in per radian. So convert into per degree, because here you will put the IT and epsilon naught in degree. So minus 2.4 something you got, na, 2.68 minus 0.75. So if you solve this, you will get CL naught of the complete UAV is 0.13351. So you can make the observation that, okay, when you add the tail, then CL alpha of the complete UAV will be more than the CL alpha of the wing alone, but CL naught of the complete UAV is less than the CL naught of the wing alone. So in 8th question, you have to find the trim lift coefficient of the whole aircraft. So this is very straightforward. When you are flying at trim condition, means your forces and moments are balanced. So that means you can write thrust equal to drag and lift equal to weight. So we want CL, so we will use lift equal to weight, because in that expression the CL will come. So use this relation half rho V square S into CL. So rearrange this, CL equal to 2W divided by rho V square S. So put this value 2 into the weight is given, 850. So please note down that 850 kg is the total weight, because at the beginning of this lecture I think we missed this weight. So please note down this. So weight will be the 850 kg and rho mean sea level 1.2256, 1.225, take 3 digits. V speed is given already 45, this is V square 45 square, and area of the wing is nothing but, this is also given that the you have to take the rectangular shape of the wing. So your area will be nothing but B into C bar. So B is given how much? It is 10.5 and C bar is given 1.2. So area, your area will come around 12.6. Let me check. Yes, 12.6. So 12.6. So if you solve this, you will get 0.533 is your CL value. Okay. This is the 8th question. So in 9th question and 10th question, you have to find the trim angle of attack of the aircraft, and to trim this aircraft at that particular angle of attack, which we will find in next question, how much the elevator deflection is required in order to trim the aircraft. So we will solve this. See, whenever you deflect the elevator, the aircraft will respond. If the elevator go up, the nose part will go up. If the elevator will go down, then the nose part will go down. So basically you are controlling the plane in longitudinal motion using elevator. So basically when you use the elevator, means you are controlling the angle of attack. You are trimming the angle of attack at different angle of attack with different velocity. So this is the significance of this question. So let's solve this question. So you know that, okay, if you observe this equation, CL equal to CL alpha into alpha plus CL delta into delta E, this CL alpha is nothing but complete CL alpha of the air vehicle, which we have already found. This is a angle of attack. This is a, when you change the angle of attack, when you change the elevator angle, how much CL will change. So this stability will tell, this stability derivative will tell, and this is the elevator deflection. In this moment equation, Cm equal to Cm naught plus Cm alpha into alpha. This Cm alpha is nothing but Cm alpha of the whole air vehicle. This Cm naught is the Cm naught of the whole air vehicle, and plus this Cm delta is depend upon the, okay, how much aircraft will respond, like in terms of moment when you deflect the elevator. This Cm delta is nothing but elevator control power. So whenever you are trimming, means you are balancing the moment, means net moment will be the 0. So the Cm naught will be the 0. So use this equation 1 and 2, this make 1 and this 2, you will get the answer of 9th and 10th question. In, if suppose the aircraft is trim, so then equation 1 becomes CL trim equal to CL alpha of the whole air vehicle or the air vehicle into alpha trim plus Cm delta E into delta E trim, right? And your second equation become, see, aircraft is in trim condition, so net moment will be the 0, means Cm will be the 0. The 0 equal to Cm naught plus Cm alpha into alpha trim plus Cm delta E into delta E trim. So you can make equation 2, 1 and 2 you have already made that. So let us make 3 and 4, okay. So see this equation and you just figure out that, okay, how much unknown we required, which variable we don't know. See, CL trim you know, you already found out 0.533, CL alpha you know, Cm alpha you know, Cm naught you know, alpha trim and delta E trim you have to find. Two things you don't know, Cm delta E, CL delta E and Cm delta E. So let us find the Cm delta E elevator control power and this CL delta E using this equation. So your CL delta is nothing but tau eta St by S into CL alpha of the tail. So tau is nothing but 0.4, St by S is nothing but 1.4, CL alpha of tail is nothing but 3.38 per radian. So your CL delta E will come approximately 0.30082. Similarly, you can find Cm delta E elevator control power, it is minus eta Vh, Vh you can add St by S into tail arm divided by C bar. So minus eta Vh CL alpha of the tail into, you can multiply by tau. So you will get the answer 0.89 into what is your Vh 0.5461 I think. Your eta Vs CL alpha tail is 3.38 per radian into tau, okay. So your answer will come minus 0.657231 per radian. So you know CL delta E, you know Cm delta E. So you have two equations, two unknown, you can solve easily. But if you write equation 3 and 4 in matrix form, then it will be very easy to solve this. So let's write equation 3 and 4 in matrix form. So when you write in matrix form for equation 3 and 4, what you will get? Cm alpha, Cm delta E, Cl alpha, Cl delta E, that is one matrix, multiply by the unknown column matrix alpha trim, delta E trim, equal to, if you put Cm naught in that side, this will become minus Cm naught, and Cl trim in 3 equation, that is say Cl trim will come here. So if you multiply by this and this, compare with this, you will get equation 4. If you multiply this row to this column equated to this, you will get the equation 3. So basically you can say that, okay, this is matrix A and this is matrix X unknown and this is matrix B. So you want X, right? So X will be A inverse B. This will be your solution. So in this equation you already know Cm alpha, Cm delta E, which we found just before. Cl alpha you know, Cl delta E we found just before. Alpha trim, delta E trim we want. Cm naught we know, Cl trim we know. So put all the value in this matrix, take the A inverse, multiply by the B matrix, you will get the answer. So inverse easily you can take using this. Suppose that you have 4 element A1, A2, A3, A4 and you want to take this is A, and if you want to take the inverse, in this case you have to take the inverse of this, right. So this is inverse is nothing but this divided by determinant A, okay. Change this A4, interchange these two and put minus sign here, minus A3 minus A4, you will get the A inverse. So these things you can change, put here this two interchange, put these things with minus sign, take the determinant divided by determinant, you will get the A inverse. This will be the very easy to solve. Okay. So A inverse is nothing but adjoint of A divided by determinant of A, which we have written there. So what will be the your A inverse will come? So your X is nothing but alpha trim and delta E trim is equal to A inverse, right. A inverse which will come 0.0887 minus 1.6581, 0.1937 minus 0.2983, 0.0928, 0.533. See, this thing we are calculating in the radian, because you have, if you put, you are putting this Cm alpha, Cm delta E, Cl alpha, Cl delta E is per radian, and we want the answer in degree. So you can multiply by 180 by pi. So what you will get? Alpha trim angle of attack is nothing but 5.4438 degree, and your This is your answer of 9th question, and delta E trim will be minus 0.2937 degree. This is your delta E trim. The minus sign indicate that you are deflecting the elevator in upward direction in order to trim the aircraft at 5.4438 degree. So, this is the answer of 10th question.